Friends, welcome to ZimSick Robotics Lab. With me, the Zim Science General. This is a series of videos where we cover combined science syllabus topics from Form 1 to Form 4. So watch this video to understand the following topic better. We are discussing Ohm's law in this video. Ohm's law states that the current flowing through a conductor or flowing in the circuit is proportional to the voltage applied across it, provided that resistance remains constant. Ohm's law is expressed by the formula voltage is equal to current times resistance. Voltage is abbreviated as capital letter V, current capital letter I, and resistance capital letter R. Then where voltage is the potential difference, or PD, measured in volts, current is the flow of electric charge, remember that, which is measured in amperes, capital letter A as the abbreviation for ampere. Then resistance, which is the opposition to the flow of electric charge, is measured in ohms. Every electrical gadget resists or opposes the flow of electric current, and the SI unit is an ohm. Then the following is correct about Ohm's law. There is a direct proportionality or a direct relationship between voltage and current. If you increase voltage, automatically current increases, but assuming that resistance is constant. There is also an inverse relationship between resistance and current. If resistance increases, then current decreases. We represent Ohm's law graphically as follows. Here we have current which is measured in amperes, then voltage on the horizontal or x-axis, which is measured in volts. Then what are the limitations of Ohm's law? Ohm's law only applies to metallic conductors, where current remains constant regardless of the applied voltage. It does not apply to non-metallic conductors like graphite, like dilute acids, and the semiconductors. Calculations involving Ohm's law. For you to easily master the formula for calculating the three variables in Ohm's law, voltage, current, and resistance, you can make a triangle like this, where if you say you block V from vision, it becomes voltage, current times resistance. Then if you block R, resistance, R, it becomes voltage over current. Then suppose you block the current, current becomes equal to voltage times resistance. Let us now consider the following worked examples. Find the current flowing in the circuit diagram below. This is the circuit diagram where we have two cells of 1,5 volts each, a 2 ohm resistor, and the unknown current flowing through the circuit. Then how do we solve it? We first write Ohm's law, where voltage is equal to current times resistance. Then our voltage is 3, 1,5 plus 1,5. Then our current, we don't know, is unknown, and our ohms, our resistance is 2. We normally do not encourage you to write units in an equation. So 3,0 divided by 2 divided by 2 to get the ampere, then the current becomes 1,5 amps because current is measured in ampere. Then second question, find the resistance of an electrical device connected to a 12-volt battery, allowing a current of 2 amps to flow through it. Then you write solution, you write again the equation for Ohm's law. Then voltage is 12, current is 2, then resistance is unknown, it's R. Then when we do our calculations, our resistance becomes 6 ohms. What are the factors affecting resistance? We start by looking at cross-sectional area, which is the thickness of the conductor, like wire, for example. The thinner the wire, the bigger is the resistance. A thinner wire is a small cross-sectional area. So therefore, there is an inverse relationship, an opposite relationship between cross-sectional area and resistance. Then it can be mathematically written as follows, saying that resistance is inversely proportional to thickness. Look, the smaller the wire, the greater the thinner the wire, the greater the resistance. The bigger, the thicker the wire, the lower the resistance. Then we also have length of the wire, which is an L. The longer the wire, the bigger is its resistance to the flow of current. There is therefore a direct relationship between length and resistance, and mathematically we can say R is directly proportional to length. Then we also have temperature. Higher temperatures usually result in a higher resistance to the flow of current. Why? Because when temperature is high, particles vibrate faster, disturbing or colliding with the charge, disturbing it, resulting in a higher resistance. Then there is a direct relationship as shown by this equation. Then verifying Ohm's law, we need to verify Ohm's law that voltage is equal to current times resistance, but we are going to do this in the next video. Thank you. Thank you for watching this video. Please like, follow, and subscribe to our Facebook page and YouTube channel.